Refraction. When traveling through a vacuum, light always travels at a constant velocity of c, 3 times 10 to the 8th meters per second, so c is the speed of light. However, light slows down when traveling through a medium that is not a vacuum. The index of refraction of the medium, little n, is the ratio of the velocity of light in a vacuum, c, to the speed of light in the medium, v. Light also sometimes changes direction when it enters a new medium. This is called refraction. The angle of incidence here is related to the angle of refraction here. When the ray goes from less dense to more dense, so from air to water, it bends towards the normal line and the refracted angle is smaller. And when the ray goes from more dense to less dense, it bends away from the normal line and the refracted angle is larger. This is why objects look weird if they are partially underwater. So see how the straw looks broken? This is due to refraction. When a ray of light goes from a more dense medium to a less dense medium, if the incident angle here is just big enough, the refracted ray will be parallel to the surface. So the refracted angle will be 90 degrees, right here. This angle of incidence here, is called the critical angle. When this happens, none of the light is able to escape the denser medium. When the angle of incidence is larger than the critical angle, no light escapes the medium. This is called total internal reflection. So here you can see the light escapes and it refracts, so it bends away from the normal line. Here, this is the critical angle because you can see all the light is going this way. It's not leaving. But if this angle of incidence is larger than that angle, then actually, instead of refracting out, it just reflects back in with the, so therefore the angle of incidence here would be equal to the angle of reflection. Here's a photo of a red laser being shot into a glass of water at a wide enough angle to demonstrate total internal reflection. So here's the normal line. This angle is the angle of incidence, and it is larger than the critical angle for these two mediums. Therefore, it won't refract through at all. It will reflect, and the reflected angle is equal to the angle of incidence because this is the law of reflection. When light hits the surface of a medium, it both reflects and refracts. For example, see what happens to a ray of light as it goes from water to air. So you can shoot straight through, but some of that light actually is reflecting back. But as soon as you hit that critical angle, the light stops refracting through the surface. It's only reflected back into the water. And actually that reflected ray gets much brighter because now it's not being split up into two rays like this. Once it totally internally reflects, it's very bright ray of light. Diamond has an index of refraction, n, of 2.42. What is the velocity of light when it travels through diamond? The speed of light in air, or you could think of this as a vacuum, is 3 times 10 to the 8th meters per second. All right, so we have our equation for the index of refraction. But we're not solving for the index of refraction, we're solving for v, the velocity of the light in the diamond. So we need to solve this equation for v using algebra. The first step is to get v out of the denominator here. So we're going to multiply both sides by v. That way, it will cancel out on the right side. So we have v and v. That'll cancel out, leaving us with just v times n on the left and c on the right. Then finally we have to get rid of that n. We're going to divide both sides by n so it cancels out on the left and we get the n in the denominator here on the right. Therefore, the velocity of the light through the diamond is the speed of light in a vacuum divided by 2.42. And that gives us 1.2 times 10 to the 8th meters per second. So you can see that the speed of light in diamond is less than the speed of light in a vacuum, 2.42 times less. If the velocity of light when it travels through an unknown medium is 2.25 times 10 to the 8th meters per second, what is the unknown medium? The speed of light in air is 3 times 10 to the 8th meters per second. So in this problem, to figure out what the medium is, we're going to have to find n. So we have our equation, n equals c over v, and we don't have to do any algebra because it's already solved for n. So we just have to plug in c, and we plug in the velocity of light in the mystery medium, and we see that the ratio is 1.33, telling us that that medium must be water.